Good morning, students. In our last class, we have discussed some of the numericals based on dimensional formulas, right? That numericals were based on checking the correctness of any of the formula, right? With the help of dimensional formula, we can check that any formula is correct or not. Now, today we are going to discuss the another form of numericals that are based on dimensional formulas, in which we can derive any of the formula by knowing that on what factors, on what physical quantities a basic quantity based on. Okay, किसी एक कोई एक फिजिकल क्वांटिटी अगर दूसरे फिजिकल क्वांटिटीज पर बेस्ड होती है, तो उसकी हेल्प से हम उसका फॉर्मूला डिराइव कर सकते हैं. दैट टुडे वी आर गोइंग टू डिस्कस दैट. ओके, so first of all we will see first question, that the time period of a simple pendulum depends on effective length of the pendulum and acceleration due to gravity. Now we have to deduce the formula for this. Okay, so let t be the time period, effective length be denoted by L, and acceleration due to gravity be denoted by small g. Then as per our question, we can say that this t is proportional to L and g, right? यही बोल रहा है हमारा क्वेश्चन, that the time period of the simple pendulum depends upon the effective length and acceleration due to gravity. Now here there can be any power of this L and G, right? We have to consider that the power of L is A, let, and the power of GB small b. Now if we remove this proportionality sign from here, then it will become t is equal to k and L to the power A, G to the power B. Okay, now where this k is a constant, and we know that the there exists no dimensional formula for any of the constant. Now we should know the dimensional formula of all the physical quantities that we are using here. So we know that the dimensional formula of time period is m0 L0 t. Similarly, the dimensional formula of length is m0 L t0, and the dimensional formula of g is the acceleration due to gravity. That is one type of acceleration. So what the dimensional formula of acceleration will same be the dimensional formula of g as well. So we know that the dimensional formula for acceleration is m0 L t minus 2. So and there is no need to write the dimensional formula of k, as k is constant here, right? Now on putting all these values in our equation 1, what do we get? It will become m0 L0 t is equal to k into m0 L t0 to the power a dot m0 L t minus 2 b. Okay, now if I compare the powers of m, L and t individually in both LHS and RHS, then what I do get? Here m is 0, m is 0 and m is 0. So I don't need to write the equation for m, as it is 0 on both the sides. Okay, so now now I will see the power of L. Here the power of L is 0 is equal to, here the power of L is 1, and 1 into A will be A, right? Plus here the power of L is 1 and 1 into B is B. So we can say A plus B is equal to 0. This is our first equation. Okay, what we have done, we have just compared the powers of M, L and T. M की पावर दोनों साइड 0 थी, इसलिए हमने उसको नेग्लेक्ट कर दिया. L की पावर यहाँ पे LHS में 0, so we have written 0 here. Here the power of L is 1 and 1 into A is A, plus here the power of L is 1 and 1 into B is B. Now similarly we will compare the power of t's. Here the power of t is 1. So I can write 1 over here. 1 is equal to here the power of t is 0 and 0 into a is 0. So we don't have to write anything. Plus here the power of t is minus 2 and minus 2 into b is minus 2b. So I can say minus 2b is equal to 1. Minus 2b is equal to 1, or I can say b is equal to minus 1 by 2. And on putting this value of b in our equation 1, I can get a is equal to 1 by 2 and b is equal to minus 1 by 2, right? So on putting the values of a and b in our equation number 1, what I will get? I will get t is equal to k as it is l to the power 1 by 2 into g to the power minus 1 by 2, and I can write it as k into l upon में g का whole under root. And this is the formula for time period of a simple pendulum undergoing SHM, that is simple harmonic motion. Okay, and this is how we can derive any of the formula by just knowing that on what factors does this physical quantity depends. Okay, so I hope the numerical is clear to all of you. We will practice one more numerical based on this type only. Now in the second question, which is given to us, it states that the velocity of sound wave in a medium depends upon the coefficient of elasticity. अच्छा, coefficient of elasticity एक तरह की physical quantity होती है that we will discuss later. Okay, when we will discuss the mechanics of solid, in that we will discuss this. Just for now, understand it like this only, that the coefficient of elasticity is a physical quantity. So what does the question states us? The question is saying that the velocity of the sound wave depends upon the coefficient of elasticity, which is denoted by E, and density, which is denoted by rho. Now we have to establish the formula for this as well. Okay, so जैसा हमने previous question में किया था, we have to consider any of the power of this E and rho, right? So let the power of E is A and the power of rho is B. Now if I remove this proportionality sign from here, then I have to introduce a constant, and let that constant is K. So I can write it as this. On removing the sign of proportionality, I can write equal to here, and K is the constant. Now I have to write the dimensional formula of all the physical quantities that we have used here. So the dimensional formula for velocity is m0 L T inverse. The dimensional formula of coefficient of elasticity is m L inverse T inverse square. For now, just learn it like this only, that the dimensional formula of E is m L inverse T inverse square. ये कैसे आया, this I will explain it to you later when we will discuss mechanics of solid. Okay. Now the dimensional formula of density is, density का formula होता है mass upon volume. It will become m L inverse cube T0. Okay. Now from here, what do we get? We will get, on putting all these values in our equation 1, what do we get? m0 L T inverse is equal to K. E की जगह हम लिख देंगे m L inverse T inverse square to the power A into m L inverse cube T0 to the power B. Okay. Since A is a constant term, so there will not be any dimensional formula of this K. So we can neglect this K. Okay. We can neglect this K just for now. So what do we get from here? On comparing the powers of m, On LHS the power of m is 0 is equal to, here the power of m is 1 and 1 into a is a, plus here the power of m is 1 as well, 1 into b is b. So we will get our equation 1 as a plus b is equal to 0. Then on comparing the powers of L, I will get the power of L in LHS is 1. Here the power of A is minus 1 into A, so it will become minus A, and here the power of L is minus 3, so minus 3b is equal to, so what we will get, 1 is equal to minus A minus 3b. Similarly, on comparing the powers of T, in LHS I will get minus 1 and in RHS minus 2 into A will become minus 2A and 0 into B is 0. So it is not needed not to write anything here. So from here what do we get? Minus A minus cancel. A is equal to 1 by 2 and from equation 1 we will get B is equal to minus 1 by 2. Right? So we have got the value of A and B. So on putting both these values in our equation 1, what do we get? V is equal to K e to the power 1 by 2 into rho to the power minus 1 by 2, which means E upon में rho का under root, and this is the formula for the velocity of a sound wave which is traveling in the medium and which depends upon the coefficient of elasticity and the density of that medium. Okay, now we will practice one more question based on this type, and that question is, now there are two more questions. As you can see here, we are going to solve these two questions. Okay, so what does the question is saying? The centripetal force capital F acting on a body may depends upon the mass of the body and radius of circle and frequency of revolution. Now there are three physical quantities given to us on which the factor centripetal force depends. Okay, so let us see how to solve this numerical. What the question is saying, the force is directly proportional to mass, let it is denoted by small m, radius, let it is denoted by r, and the frequency, let it is denoted by nu. Okay, so here the power of m is A, r is B, and nu is C. If we remove this proportionality sign, so what do we get from here? We will get F is equal to K, m to the power A, r to the power B, and nu to the power C. Okay, so now we have to write the dimensional formula of all the physical quantities that we are using here. The dimensional formula of force is, we know that mass into acceleration, that is mlt inverse square. m का dimensional formula हो जाएगा, it will be m1 L0 T0, r is equal to m0 L T0, and frequency, that is nu, is equal to m0 L0 T inverse. Okay, so now on putting all these values in our equation 1, suppose this is our equation 1, what do we get? m L inverse square is equal to K, where this K is the constant, so there is not any need of writing dimensional formula for this, because we know that the constant terms are dimensionless. Okay, from here, on comparing the powers of M, L and T separately, what do we get? First of all, on comparing the powers of M, so here the power of M is 1, so 1 is equal to, here the power of M is 1 into A, that is A, here the power of M is 0, so 0 into B is 0 and 0 into C is 0 as well. So what do we get? A is equal to 1. Similarly, here on comparing the powers of L, here the power of L is 1, so 1 is equal to, here the power of L is 0, 0 into A is 0, here the power of L is 1, 1 into B is B, and here the power of L is 0, so we don't have to write anything here. This is our equation 2, okay, let it be equation 2, this is 3, and this is on comparing the powers of t, what do we get? Minus 2 is equal to 0 into A is 0, 0 into B is 0 as well, minus 1 into C is minus C. So directly we will get the values of A, B and C. Now on putting the values of A, B and C in our equation 1, what do we get? We will get F is equal to K into M to the power A, that is 1, R to the power B, that is 1, and nu to the power minus 2. On putting this, what we will get? M R upon nu square. Okay, so this will be the formula for the centripetal force which depends upon the mass, radius and frequency. Okay, so I hope it is clear to all of you. Now if we proceed toward our second question, okay, okay students, minus से minus cancel हो जाएगा and here we will get C is equal to plus 2, that is V nu square. So what do we get from here? F is equal to K M R nu square. Okay, minus से minus cancel, so C is equal to 2. On putting this value we will get nu square, and the formula will be F is equal to K M R nu square. Okay, now for the last question, we will go for the last question now. What do we get? What does the question saying? The wavelength lambda of the matter wave may depends upon the Planck constant, mass and velocity. Okay, what does the question is saying? The wavelength lambda is depends upon the Planck constant h, the mass and the velocity. Let the power of h, m and v be a, b, c respectively. So on removing the proportionality sign from here, what do we get? Lambda is equal to k h a m to the power b and v to the power c. Okay, this is our equation number 1. Now on putting the values of all these physical quantities, what we know that the dimensional formula of lambda is m0 L T0. The dimensional formula of h, that is Planck constant, it will be m1 L2 T minus 1. The dimensional formula of mass is m L0 T0, and the dimensional formula of velocity is m0 L T inverse. Okay, now on putting all these values in our equation 1, what do we get? m0 L T0 is equal to k into h की जगह हम लिखेंगे m L square T inverse to the power a. स्मॉल m की जगह हमने लिखा m L0 T0 to the power b, and v की जगह हम लिखेंगे m0 L T inverse to the power c. Now what do we get from here? On comparing the powers of m, l and t respectively, so in LHS the power of m is 0 is equal to, here the power of m is 1, 1 into a is a, here the power of m is 1 as well, 1 into b is b, and here the power of m is 0. So we don't have to write anything for this because 0 into c is 0 itself. Now on comparing the power of L, L is equal to 1, यहाँ हो जाएगा 2 into A is 2A. Here it is 0, so 0 into B is 0 as well, and here the power of L is 1. 1 into C is C. This will be our equation 2. And on comparing the powers of T, what do we get? 0 is equal to minus A minus C. This is our third equation. Okay. Now, on solving all these three equations, what do we get? We have to solve all these three equations. From here we can get A is equal to minus C, and on putting this value in equation 2, what do we get? 1 is equal to 2 into minus C plus C. 1 is equal to minus 2C plus C, or minus C is equal to 1, or C is equal to minus 1. Okay. And if C is equal to minus 1, then A is equal to plus 1, and from here if A is equal to plus 1, then B is equal to minus 1. So here we get all the values of A, B and C, and on putting all these values in our equation 1, what do we get? Lambda is equal to K into H to the power 1, M to the power minus 1 and V to the power minus 1 as well. So lambda is equal to K into H upon में MV. Okay, lambda is equal to K upon में K H upon में MV, and this is the formula for the wavelength of a many matter wave, which depends upon the Planck constant, mass and velocity. So I hope all these kind of numericals are clear to all of you, and you will be able to find out the formula by knowing that on what factors does a physical quantity depends. Okay, that's all for today's session. Thank you.